so we can get started. All right, well, this morning we're going to be looking at Chapter 6 of our textbook on the topic of percents. And as you can see on your screen right now, percents are really super critical to business. If you think about it, everything in business is basically expressed in terms of percents, right? Percentage of sales, percentage of loss, percentage of markup, percentage of markdown, percentage on loans, percentages of interest. So everything is pretty much determined and expressed in terms of percents. And so we have to understand then how to first convert percents and decimals. So basically converting a decimal to a percent, because pretty much all mathematical processes need to be done with the decimal equivalent of the percent. So if we say, well, I want a 25% markup on all my products that I buy and resell, then I need to multiply the amount that I bought it for by 25%, which would be the same thing as a 0.25 decimal, and that'll give me the amount that I would need to mark it up. So percents need to be converted to decimals before mathematical equations can be figured out. And so it's very important to know how to convert them both ways, whether it be a decimal to percent or a percent to decimal, because many times, again, you might have your answer and now I want to convert that to, well, what is that in percent? So I need to convert my decimal answer to a percent. So that way I know exactly what percentage we're talking about. So that's what this chapter starts out with. It's very basic, but then when you get into some of the word problems, it becomes a little more challenging, and they introduce you to a little triangular formula that we'll look at here in a minute that really helps you to kind of put in perspective how to solve the math problems and whether you're solving for what percentage rate it is or what amount of markup you want, or what was the original selling price if it was marked down a certain percent, things like that. And so we'll utilize that little triangular formula that they give us, because it'll be something that we use from now until chapter 10. And then at chapter 11, we're going to start something new. So basically from chapter 6 to chapters 11, they utilize this triangular formula, and then they basically keep adding on to it to help you solve some of the various problems that we'll be experiencing. So your chapter starts out with really just how to convert decimals to percents, and then how to convert percents to decimals. And it's a very simple mathematical process. If you notice here, I have rule number 1 on your screen. Basically, in order to take a decimal and make it a percent, you just need to multiply that number by 100 and then add the percent sign. So there's a couple of examples here. You have 0.7 times 100 comes out to basically 70%. So your answer is going to be 700, and then you're going to create it. It's going to be 0.700, and you're going to make it a percent by moving the percent sign. So basically, you can just multiply it by 100, and you'll have your answer. So 4.5 multiplied by 100 is 450%. 3/5 or 0.6, you convert the fraction to the decimal. By the way, you convert the fraction to the decimal by dividing the numerator by the denominator. So in this case, it would be 0.6. 0.6 times 100 comes out to 60%. So you're basically doing it that way. But an even easier way is rule number 2, and that is just simply move the decimal point 2 spaces to the right and add the percent sign. And that's how you can convert them much more quickly. So for instance, if you take 0.6 and you move your decimal point, as it says here, 2 points over, so 1, 2, and basically add the percent sign, your answer would be 60%. If you take the next one, 3.7, so 370. So I moved my percentage point over, added a 0. My decimal point gave me 370%. Same thing here. If it's 4 point to make 4, I move it over 2 spaces and add 2 zeros, 400%. So that's pretty much the easiest way to do it. 0.875 basically becomes 87.5%. So it's simply just moving that decimal point 2 spaces to the right and adding the percent sign. That's the easiest way to do it. So rather than do the math and multiply it by 1,000 or 100, excuse me, just much easier to move the decimal point. And this is something that you can do in the top of your mind as you're working out math problems. Your answer comes out 0.6. What is that in percentage? Move the decimal point 2 spaces, add a 0, add the percent sign, 60%. and it just makes it a lot easier for you to be able to quickly convert the decimal to a percent, and then vice versa. When we get to percents, we're going to need to convert them to decimals so that we can do the mathematical process. So that's page 1 of our notes. I'm going to go ahead and open the second page here, which is a little bit more on this. So why don't you take a minute? I'm going to give you guys a few minutes to go ahead and work through converting a few of these percents, decimals to percents, and then I'll come back and show you all the answers in just a second here. So take a few seconds, do a few of these, if you would, on the screen, and then we'll come back and I'll have you guys shout out some of your answers. All right, so I converted all of these for the most part. Did you guys do any before I did, or I probably should have given you a little more time and then wrote them in, but any challenges to this? As was just questioned when I wasn't recording, we did have how do you convert the fraction to the decimal, and you'd basically just divide the numerator by the denominator. So the 3/8 example, 1.1538, you just divide the 3 by the 8, and it comes out to 0.375. So you would add that to the end of the number, but the decimal point was after the 1, so you would just add the 375 after the 15. And then in this case, I moved the decimal point 2 places to the right, so it came out to 115.375%. All right, so I'm going to move on then to converting percents to decimals. And again, you can do it mathematically. In this case, rather than multiplying your percent by 100, you would divide your percent by 100 and remove the percent sign. So for instance, if you look at the first example here, 27% converted to a decimal would be the same equivalent as 27 over 100. And if you divide that, it would be 0.27. So all we did was really remove the percent sign and move the decimal point 2 spaces to the left. So if we go to the next example, we have 93.7. We divide 93.7 by 100. It comes out to 0.937. So that would be the decimal equivalent. The 12 3/4, we'd have to first convert the 3/4 to 0.75, which is what the decimal equivalent of 3/4 is. So it would be 12.75 divided by 100, or 0.1275 would be the decimal equivalent. So you do the same thing on these. The rule 2, same thing as I showed you before. Rather than moving the decimal point 2 spaces to the right to make a decimal a percent, when it's already a percent, you can remove the percent sign and move the decimal point 2 spaces to the left. So the example I give you right here is 1.21%. We'll remove the percent sign and move the decimal point 1 point and 2 points to the left. In this case, you'd have to add a 0, so your answer would be 0.121. Again, on 121%, if I was to move the decimal point 2 spaces to the right, it would come out to 1.21 decimal. Same thing, 42.86% is the same thing, decimal equivalent of 4286. I move the decimal point 2 spaces to the left, or 1.12516. 16 is the equivalent of 167. So in this case, it would be 125,167. Then I would move it 2 spaces to the right. So my answer would be 1.25167. Now, this is very important. This is probably the most important thing, is when you're getting ready to do math, any kind of calculation that involves a percentage, you have to first convert the percent to a decimal, then do the mathematical process. And then if you need to reconvert back to a percent, then you would reconvert back to a percent. So I'm going to go ahead and share the next screen and give you a chance this time to go ahead and give me some of the answers. So let's open page 3. And there's a few here across the top. So take a few minutes and see if you can convert those percents to decimals. And this time I'm not going to fill them in. I'm going to fill them in when you give me the answers. So, all right. All right, well, let's give this a shot. Let you guys shout out some of the answers that you got, and any ones that you don't, I'll go ahead and complete. But what did you guys get for 0.05%? What would that be in a decimal equivalent?
I kept that one the same as 0.05 because you have to take away the percentage sign. And then when you move it to the left 2 spots, it lands on 0.05. Or would I not?
So that would be your answer. So again, you'd move the decimal point 2 spaces to the left and then add zeros to make up for it. So 0.0005 is the same as 0.05%.
Yeah.
So how about the next one? 3/5.
Would that be like 0.006? Or would it just be 0.06?
It would be 0.006. So
Oh,
when you convert the decimal, it comes out to 6. Now, the one thing you
Yeah.
have to realize about percentages is they're always a portion of a whole, right? So in this case, you're talking about 3/5. So 3/5% is the same thing as 0.6 decimal, correct? And and it comes out, then you move the decimal point, that would be 0.6%. Still a percentage. Now you need to move the decimal point 2 spaces to the left, so it comes out to 0.006 decimal. So how about 6.5? Eduardo, you want to give that a shot?
Yeah, 0.0625.
Actually, it would be 0.065 because 0.1 is the same as
Oh, yeah. Sorry about that. I for some reason put the original one as 6.25 instead of 6.5.
You got it, but you had it right, 0.065. So you were on the right track. How about the next one, 2000? How would you make that into a percent or to decimal? Sorry. So again, just remove.
That one I just got 20. 20.00.
Pretty much it. 20. It's a whole number. Yep. All right. How about 27.27%?
Would that one just be 0.27?
Yep. 0.27. You got it. You guys are on the right track. How about 472%?
4.72.
4.72. Yep. So it would be a whole number plus 0.72, a portion. Then 9 1/3. 1/3 comes out to 0.333 indefinitely. So you could just round it off, but basically it would be 0.933. That would be your decimal equivalent. So if you see, something like the interest rate is going to be 9.1%, then you need to convert that to a decimal by moving the decimal point 2 spaces to the left, adding the 0 and moving the percent sign, and it would be 0.0933, and that's what you'd multiply your number by. If you're going to say, I have $100,000 and they're going to pay me 9.33% interest, how much interest would that be for the first year? And then you can multiply it and you'd find out what your interest is. So 7/8 is the same thing as 0.875. So that would be the decimal equivalent of 0.0875, because all I did was move the decimal point 2 spaces to the left. 1/8 would be the same as 125 or 0.00125 decimal. 0.68, 0.0068, 44. Oh, that would be 0.44. And then 56.4 would be 0.564. So all I did was move the decimal point 2 spaces to the left, and that gave me the decimal equivalent. And of course, wherever the percent is, if there's no decimal point, that's assumed where the decimal point is, right? Not assumed, but that is where the decimal point starts. So there's your answer to all those. They're not too difficult, so we'll kind of put it to practice here down at the bottom. I crossed out this middle one because it really is not relevant. You're just taking the decimal equivalent. Well, you could do that, the decimal equivalent of each of the cookies. So chocolate chip, if it's 53%, would be the decimal equivalent of 0.53. The peanut butter cookie at 16% would be the equivalent of 0.16. The oatmeal cookie at 15% would be the same as saying 0.15. Sugar cookie at 11% would be 0.11, and then the other cookies would be 0.05. And then if you wanted to do the reduced fraction, you could just do 53 over 100, 16 over 100, and you'd actually reduce these down. I'm not going to reduce them. but they do reduce down and then be 5 over 100. And you can reduce those, some of those down, some of them you can't go down. Like for instance, this one here is 4/25. But I don't really care about that. What I care about is the one below it. So this is Walt Disney's company, and they have, if you add all of them up, you get the total number of sales. So if you add 16.9, 10.7, 6.1, and 2.4, you add it all up, they have a total sales for all of their different departments of 36.1 billion. Okay. So they're asking you, well, then what is the percentage of each of the different departments? So for instance, media networks, if it's 16.9% of their total, then all I would need to do is take the 16.9, and these are dollars, divided by the 36.1, and that would give me a total of 46.8. So that would be $46.8 billion of each one. So does that make sense? So that's the dollar value of each one, 46.8. Sorry, hold on. Percent, sorry. So if you do the math on that, if I do 16.9, I'm just going to do it 16.9 divided by 36.1, it's going to give me an answer of 0.46814, goes on. Okay, so that was my answer of the math, but I needed to convert it to percent. So I had to move it over 2 spaces, and that gave me my 46.8%. So again, the same thing. If I took my parks and resorts income and it was 10.7 million, I would divide it by 36.1, which was the total. So 10.6 divided by 36.1 equals equals 0.29362. So you don't have to do the whole thing, just at least enough to give you an example of where you can round it. So if I did 0.2936, what does that come out in percentage? It would be 29.4%. So I would round that 3 up by using the 6 that's after it, right? So whenever it's 5 or above, you round up. Whenever it's below, you would round down. In this case, we're going to round up. So it's 29.4% of their parks and resorts sales.
Professor?
Yes.
On my calculator, the 10.7 divided by 36.1, I get 0.296.
I think I actually did it. I punched in the math wrong. Let me try it. 36.1?
Yeah, I believe that answer should be 29.63%.
63. Yeah, you're right. I actually put in 10.1 instead of 10.7 when I did the math. So good catch. So the next one, 6.1 divided by 36.1. That would be the studio entertainment. So you can do that one. 6.1 divided by 36.1. That time I got the ones right. Equals 0.16897. So how would you convert the answer to that one in percents? If I did just to the
Would it
just
be 16.9?
16.9%. Yep. You got it. Anyway, that's how you would utilize finding the percentage. Now remember, percentages always represent a whole. So whenever we say a percentage, it's a proportion of the whole. And that's an important distinction to make. So it'll become more clear here as we move on. So that's basically converting decimals to percents and percents to decimals. And now we're going to move on to our page number 4. And this is where we start getting into that formula that I had mentioned earlier. So I just want to spend a minute talking about this formula because it's super basic right now. A lot of this you don't even really need the formula for, but as we move further along into other problems, especially when we start getting to markups and markdowns and things like that, you're going to really want to use this formula, especially when we add a time to that as well, when we start looking at simple interest in chapter 10. So in this case, just to look at very basically, this triangle represents the what we call the portion formula. And so basically you have your rate, your base on the one side of the bottom, then you have your rate, which is your interest rate or percentage or decimal, and then you have your portion. And so the way this thing basically works is the horizontal axis, you multiply the the vertical axis, you multiply the horizontal axis, you subtract or divide. So for instance, the base or 100% portion, so base is always 100%, whatever it is. So when we looked at that problem a minute ago, we saw that Disney made 36.1 billion per year. That was everything. So that was their base. And then you multiply it by the rate or percentage, that will always give you your portion at the top. And that's true if you look at the first formula right here. Your portion always equals your rate times your base. So that's the first way of looking at this. So if we look at the first problem right here, it says, what is the portion if the base, this should say if the base, is 980 and the rate is 55%. So if I drew the little formula, by the way, I like to do the base first. It's just easier for me. So times the rate, 0.55. That's going to give me the base, or that's going to give me the portion. So what that's saying is, what is 55% of 980? 980 is the 100%. So what is 55% of 980? And we'll find out that the answer to that question is, sorry, I don't want to have to do the math on all these, so I just did it already. Comes out to 539. So what that says is that 539 is 55% of 980. And so that's what we call the portion formula. So we're always trying, with percentages, we're always trying to find the portion or the percent amount. So in this case, that would be the amount of 55% of 980. So looking at the second problem, again, we have what number is 72% of 320. So again, we could just do it this way, 32 times 0.72. That would give us our answer. Or I just want to get you used to using the formula, 3,200 times 0.72 will give us our portion. And in this case, that comes out to 2,304. So when we start dealing with word problems that are looking for the portion, the discount amount or the percentage of the amount of percent, etc., we're going to be utilizing this formula. And if you look at the example below, adventurous savings and loans requires 50% down payment on mortgage loans. What is the down payment needed to finance a $148,000 home? So 148,500 is our base, and we're going to multiply that by the 50%, and that's going to give us our answer. But again, I want you to use the triangular formula. So 148.5 times 0.50 will give us our portion. And the answer to that is 74,250. So what's that saying? It's saying $74,250 is required for the down payment because they require a 50% down on a $148,500 loan. Now, we don't see mortgages that low anymore. These problems are already outdated. But when I bought my home, I paid $150 for it back in the day, and now homes are not even anything close to that in Riverside or in California. So this is what we call the portion formula. You're just trying to find the portion, the P, the top box. But we're going to be switching it around and solving for the rate when we have the portion and base, or solving for the base when we have the portion and the rate. And this is kind of the beginning of utilizing this formula, and you can pretty much solve any of these initial problems by just simply using this triangle. So I'm going to go ahead and move on to the next page, and you'll see what I mean. So here we're going to solve for the rate. So if I use this portion formula again, so remember it was portion, base, and rate. These two multiply, these two divide. So now I'm trying to find this one here. And if it says if the base is 21 and the portion is 9, what is the rate? So I would simply do my formula. It said that the portion was 9 and the base was 21. So I'm trying to find, so I would simply divide those two. 9 divided by 21, I would divide the portion by the base, comes out to 0.42. 8. 5. I'm going to add it all because it's going to make a difference. So it depends on what they want us to round to, but let's just round to the 10th percent. So in this case, it would be the 10th percent would be 42.8. 42.9%. So 9 is 42.9% of 21. And it makes sense, right? Because if it was 10 and the base was 20, it would be 50%, right? But because it's 9 and it's 21, it's going to be a little less than 50%. So 42.9% is the rate. So in that case, if I said, well, I had a $21 investment, I made $9 off that investment. How much, what rate, what did I earn? What percentage did I earn? I earned 42.9% on my $21, if I looked at it that way. Again, the next one, 67, is what percent of 142? So if I do my little formula, my portion is always going to be the lower number in this case. So 67 is what percent of the base of 142? Again, I would divide those two. Comes out to 0.4718. Or if I was to round it to the 10th percent, would be 47.2%. So that would 67 is 47.2% of 142. So again, I hope not to insult anyone's intelligence. I'm just going over these very basically because later on this will become extremely handy for you to use, and it'll make it a lot easier to solve your problems. For instance, looking at the next one, during a recent sale, Sir John, a men's boutique, sold $5,518 in business suits. If the total sales amounted to 8,900 suits, what percentage of sales were suits? Or $189 in total sales, what percentage of those sales were suits? And so again, we know the portion, we know the base, we know that they sold 8,900, and we know that 5,518 of that was suits. So what they want to find out is what is the percentage of suits to total sales. So again, in this case, I just follow my formula. I'm going to divide 518 divided by 8,900. My answer comes up to 0.62 or 62%. So what that tells me is 62% of my total sales was suits. So we were able to solve for the rate using the portion formula, and you will have some problems like this on your quiz, as well as some problems like this on your check-in assignment. And by the way, I didn't say this yet, but your check-in assignment is really math questions, but it's all put into the context of Sienna's health and fitness. So basically, you're going to help her figure out certain percentages based off of the questions that she's dealing with, the problems she's dealing with. It's all going to be in terms of the business. So you need to know how to do these problems. Then we're going to solve for base. And again, we're using the same formula. So now we don't know what base is. So let me erase that. If I erase this here, we're going to change it around a little bit. So we're going to solve for base, but we do know the rate. So once again, we're just simply going to divide the portion by the rate. So what is the base if the rate is 40% and the portion is 690? So again, we know this is 40% and this is 690. But before we can do the math, we need to convert that to a decimal. So we take the 690 divided by the 0.40. That gives me a total of 1,725. So what that's saying is 690 is 40% of 1,725. And that's how we got our base. What was the total? We don't know, but we know the portion, we know the rate, so we know we can figure out what the base is or what the whole amount was. Again, base represents 100%. So again, this one's 550 of 88%. So 550 of 88%, we would need to convert the 88% to 0.88. Comes comes out to $625. So what's that saying is $550 is 88% of $625 in this case. So we're solving for base. We know the rate, we know the portion, so we just divide those together using our formula. And then lastly, in the machine shop, 35% of the motor repair that Zepper's broken shafts. If 126 motors had broken shafts last month, how many total motors were repaired? So again, I know the portion, I don't know the total, that's what I'm looking for. So I know the portion is 126, and I know the rate, 35%. So I would just divide those two. Comes out to 360. So what is that saying? It's saying there was 360 motors repaired last month. 126 of those had broken shafts. That represents 35% of the total motors repaired. You guys still with me? All right, moving on to the next page here, then we have a couple of other problems. These ones are a little more tricky. It says the Parker Company employs 68 part-time workers. If this represents 4% of the total workforce, how many individuals work for the company? So what we're looking for is the total, right? So in this case, since I know it's the total I'm looking for, it would be the base. And I know that we have 68 part-time employees, and that only represents 4%. Or 0.04. So if I divide 68, that means we have 1,700 individuals that work for the company. 68 divided by 0.04 equals 1,700. So I have 1,700 individuals that work for the company. 4% or 68 of those workers are part-time workers. So there I have my answer. All right. Next one, a medical insurance policy requires Anna to pay the first $100 of her hospital expense. The insurance company will then pay 80% of the remaining expense. Anna's expected a short surgical stay in the hospital, which is estimated the total bill to be about $4,500. How much will Anna's portion of the bill amount to? Okay, so they're saying it's $4,500 that she's going to have, and she's going to automatically have to pay the first 100, right? So we're going to subtract that. We're going to say Anna has to pay. So 100 for sure. But that leaves us now 4,400. And they're going to say that she has to pay a portion, a certain percentage. So 4,400 times 0.80, that will tell us what portion she needs to pay. So 4,400 times 0.80 means that, the hospital is going to pay 80% of 4,400. Sorry, 4,400 times 0.80 equals, they're going to pay 35.20 of the bill. So if they're paying 35.20 and the bill is 4,400, she already deducted the 100, we would just subtract those. So she's going to pay another $880. So she's going to end up paying $980. So again, I just took the 4,400, I subtracted the portion, and that gave me my difference between the two, which was $880. And then I added the 100 to it, so she's going to pay $980. Now you got to remember when you're doing word problems is try and make sure that you write down all the factors that you can. I probably could have written down more here than I did, but just keep in mind what their question they're asking. That's the most important thing, is what are they actually asking? So how much of Anna's portion of the bill will amount to? What is their total going to be? And it's going to be $980. So you guys follow me on that? Okay. And I utilized the portion formula to solve the problem. All right, the next thing your chapter gets into, and this is very important, is how do you figure out a rate or increase or decrease between two numbers? A rate of change is what we call it. And basically your rate of change is how much change has there been, or in this case, we can call that the portion, compared to the original amount that you're calculating it by. And this is going to become very important later on when we start doing things like horizontal analysis of your income statement or your balance sheet, because you're going to have to first find the difference or rate of change and then divide that by the original amount. And that's really what it boils down to. So if you look at the example I give there, if a number increases from 650 to 948, what is the rate of increase? Well, in order to find the rate or percentage of increase, you first have to find out the difference or portion of that rate. So in this case, 948 minus 650 equals 298. That is your difference or your portion. And then you would simply throw that into your portion formula. So in this case, 298. And we said the total was originally what? 948. So I would divide those two together. I'm sorry, 650 would be your base. That was what you always go with what you started with. My bad on that. 650. So if I divide those two together, as it says here, it comes out to 0.45867, or a 45.8% increase. So again, take your portion or the difference and then always divide it by your original amount. And that would be a 45% increase because it went from 650 to 948. So always start with your base. And your base in this case was 650. Again, a number is decreased from 21 to 15. What is the rate of decrease? So again, first thing you got to do is find out the difference. So what is 21 minus 15? Is 6, right? So I can punch 6 into my formula, 6, and then my original amount was 21. So 6 divided by 21 equals 0.2857. And so that would be a 28.6% decrease or increase. Anybody? If it went from 21 to 15, decrease. So 28.6% decrease. So if I had 21 sales yesterday and I only had 15 today, that is a 6 sales decrease, or a better way to say it is the 28.6% decrease from yesterday to today. And that's why this can be very valuable to learn. So next question, when Mike Vic Terman was promoted from supervisor to manager, he received a salary increase from $450 to $540 per week. What was the percent of change? So if I take 540 and I minus 450 just to find the difference, right? Comes out to $90 difference. So he got a $90 increase. So 90, in this case, the original amount was what? 450. So I'm going to divide those two to find my rate. So 90 divided by 450 equals 0.02, or that would be converted as 20%. So he got a 20% raise. That's pretty good. Who wouldn't want a 20% raise? So that's what Michael Vick earned. Yes.
When you're trying to find the rate of increase or decrease, the base number then that you're gonna start, or the base number that you're gonna plug into the triangle, is where the number originally started to where it went, right?
Exactly. Your original number, even if it's lower than the second number. Remember in the first question here, we had 650 to 948. I was tempted to use the 948, but then I realized, no, it has to be the original number. So whatever the original number was, that's always your base. That's always your starting point. Right? So 650 here, 21 here, even though this one went down. And then here it would be 450. So you divide 90 by 450. that make sense, Eduardo?
Yes, thank you.
All right, then finding the amount of rate or decrease, worldwide imports has a, I'm trying to think of, oh, this one is, what is the difference here? Hold on a second. All right, so here we're finding the amount of increase or decrease versus the rate. Before we were looking for the rate, now we're looking for the dollar difference of change. So in this case, the problem states, worldwide imports has a computer with 525 gigabytes. If replaced with a new model containing 60% more capacity, how many gigabytes will the new hard drive have? So in this case, we had 100% plus we got another 60% as I wrote here. So we have 1.6, 160% or 1.6. And so in this case, we would simply multiply the amount we had before by the new rate, 1.6, and that comes out to 840 gigabytes. Okay, but we're not done with the problem, right? Well, no, that's how much the new hard drive would have. And if you wanted to say the change, you would just go backwards and use the other. So basically what we were trying to find is the portion. You had 525 times 1.6 gave us the 840. So that's how much growth we saw happen. All right, looking at the next one, Overland Express has delivery trucks that cover 20% fewer miles per week during the winter snow season. If the truck averages 650 per week during the summer, how many miles can be expected per week during the winter? So if it was fewer, 20% fewer, so if we had 100% before, now we're going to minus 20%, so that would give us 80%. So that means that 80% of, they basically operated 80% during the winter, because that's 20% than the summer. So again, I would use my formula. I would say 650 miles times 0.80. That would give me my amount during the winter. So 650 times 0.80 equals 520. So I get 520 during the winter. And I get 650 during the summer. That makes sense? So in this case, what I'm actually doing is let me give a blank sheet here. I'm going to show you something. So what we're doing here is we're taking the same triangular formula. We're still dealing with the same base. So what was it again? 650. But what we're doing in both of these problems is we're altering the rate depending on the problem. So in this case, we were trying to find the portion, but the rate wasn't expressed in direct terms. For instance, it was 20% less, right? So we had to first, we could have just went 1 minus 20 equals 80. Or in the other problem, prior problem, we were adding to it. So we had, our rate was 60% more. So we added 1. And all that 1 did was put in the original amount that was already there, that it was 525 gigabytes. So what the 1 does is it puts the 525 back in your answer, and then it adds the 60% to it. And so in that case, it came out to, I think we said, what did we say? It was 840. So we just added the 1 back in. And this will become interesting when we start doing markups and markdowns, because we have 2 different formulas. Rather than this being portion, we'll call it sales price. And this will become cost later on, but I don't want to confuse you now. So we'll get to that a little bit later. All right. So I think that is it for chapter 6. Let's see, we have one more. We have 2 more problems to solve. All right. So this one says the water level in a large holding tank decreases to 12 feet if it's down 40% from last week. What is last week's level? So this one we're trying to find the base. What was the original amount last week, right? So in this case, we know it was 12 feet. We also know it's down 40% from last week. So we could do 1 minus 0.40 or 0.60, right? Because it's down 40% from last week. So that means it's 0.60. So I would divide 12 by 0.60. And that's going to tell me what. So it was 20. That was the answer. So what's that telling me? It's saying the large water level, the large loading tank decreased to 12 feet. It's down 40% last week. What was last week's level? 20 feet. You guys with me on that?
How did you get the 60 instead of the 40? I missed that part.
Because so 40%, but remember it's down 40% for last week. We'll call last week 100%, and then we'll minus 40 from it. That gives us 60. That means that this week it's 60%.
Got it. Thank you.
So yeah. All right, John Deere harvester can cover 90 acres per day with his new direct drive system. If this represents an increase of 20% over the conventional chain drive system, how many acres a day were covered with the old one? So again, we're given the portion or the new one, so we're trying to find how much was the original, right? So we said it was an increase of 20%. So that means, okay, if it's an increase, and I'm going to add 20% to 100%, so that gives me 1.2. So if I take my 90 acres, that's my portion, and I divide it by 1.2, it equals 75. So my original amount was 75, but I saw a 20% increase by using the new direct drive system. So now I can do 90. So 75 was the original amount that I did per day, but now I can do 90 per day. You guys with me? So again, by using this formula, I've been able to solve these seemingly difficult word problems. Are you guys understanding what I'm looking for? Because it's saying this is what I can cover now. That's not the original amount. So another way to kind of look at this formula, by the way, for the when you're dealing with what we call original price, you could say this is this will become more important later on, but you might say this is original price, this is sales price, this is rate. So original price and sales price. So if I know the sales price or the new price compared to the old price, then I'm, it depends on which one I'm looking for, but I can solve for one or the other depending on what they're looking for. I had a formula for that, but it's not in this worksheet. I apologize, but it is on the formula worksheet in this week's formula sheet. So make sure you check that out. But I use I think I call it the original price formula, and it's very similar, but you're just using different factors in these two spots. So you can look that up in the formula sheet. All right, that's pretty much it for chapter 6. Those are the only things that you need to study and know. So if you've gone through this with me, you might want to try working on the some of the questions from the end of the chapter exam that's there and see if you get them right. I believe the answers are all in the book, or at least the odd answers or even answers are all in the book. So you can work through a few of those, make sure you get it, and then move on to taking your quiz or completing your check-in assignment. But that's it for chapter 6. I'm going to do a separate video for chapter 7. So I'm going to pause this one and start a new one.